I sent you, then, and if you have no earthly idea what I'm talking about, it's right above wake up. I'll show you, because somebody's going to use that as an excuse. Oh, I didn't see it. Yeah, whatever. Right there. It's right above wake up. Right there. So you should be able to see that and copy it down in your notes. It's not an assignment. Please don't make this out. Please don't send me 15 questions that y'all create. I don't know where y'all get these questions. It says right here, what is that first word? I want somebody to say it for me.
Extra.
Thank you. Extra. Remember, I do all my assignments on my lab's math. So if I give you an assignment outside of my lab's math, chances are it's not for a grade. It's just extra problems. So you click on it, you copy it down, or if you want to print it out, you can print it out, but copy the problems down, but you'll know what I'm talking about by the end of the day, because I'm going to go over what I want you to be able to do with these problems. Okay, so we're going to use those as examples, or one of those as an example. All right, so let me get rid of this and move that back over to this TV screen. There we go. And a bar graph. Now, I'm not going to get into the difference between a bar graph and I'm also going to tell you this is kind of like your project. Get a pack of candy or cookies or something that has different shapes or different colors and separate the stuff in the bag. Now, the project calls for at least 10 bags. So you're talking about the little, the little Halloween packs, you buy a bag of them and it's got like 25 bags of little M&Ms or little Skittles. That's what they're talking about. Don't go out and buy the big bags. Don't do that. Okay. So I don't know how much those are, but they shouldn't be very much. You can, if you want to get cookies or animal crackers, or get the little snack size animal crackers that you put in a lunchbox. They come in a big bag or a big box with little mini packs in it. And you open it up and you count, you separate by shape or by color. And you do a frequency distribution. And then you do the relative frequency, or do a bar chart. And I'll show you how to do this in Excel. So it's not a big deal. And you do the relative frequency. Now, we're going to go over all this in just a minute. I'm going to go ahead and go through everything on the slides. I'm not going to insult your intelligence by breaking up brown, yellow, and counting. I think everybody in here knows how to count. And I think everybody knows how to, tally the marks. Okay, so I'm not going to go through that. All right, now, you do need to add up. In that bag of M&Ms, there's 45 individual M&Ms. So that is N. And that's the first thing you have to find with a frequency distribution is N, as in November. So you need to make sure you know that total, because that total is your denominator. And then you take that, each one of these is the individual numerators. So that's 12 over 45, 10 over 45, 9 over 45, 6 over 45, 3 over 45, and 5 over 45. Now, I'm going to go ahead and tell you the reason I'm going over this, and I give you some extra problems, is because I'm giving you about 4 or 5 things. Let me turn this thing off. Well, I'll turn it off when I do the document cam. There's 3 or 4 things that I'm asking for at one time. And for some people that haven't had probability and statistics before, it's a little bit overwhelming. So that's why I'm giving you extra problems, so you can get the method down, and the methods down so you don't get kind of overwhelmed. All right, so I've got, how many in here? I've got 13 students in here, and I would guess there's probably 5 that have never seen probability and statistics before. Now, mostly everybody understands how to do this and how to do this. But what I show you after this, that's where it's overwhelming because it's 3 or 4 more steps. Now, let me mention relative frequency, okay? And I want everybody to write this down. So I'm going to turn my video off and bring up my handy dandy. Wait a minute. There we go. Bring up my handy dandy document cam. I want everybody to write this in red. And that means if you got a red pen, if you don't, write it and highlight it. Very, very important. And I'm going to make this big, and I'm going to turn this off. With relative frequency, dot, dot, dot. Read the directions for rounding. Most of the time, it will tell you to round to the hundreds. But you cannot, don't take it for granted. On a test, make sure you read the directions for rounding the relative frequency. Now, I'm going to give you a second to make sure you write that and highlight it, because I'm going to go ahead and tell you now, if you don't read the directions on the test and the test tell you to round to the hundreds and you round to the thousands, I'm not going to accept it. You've got to read the directions. Part of probability and statistics is reading, and that means the directions as well as the problem. So with the relative frequency, make absolutely positively sure you know what to round to. Okay, and we're going to put some more stuff on there too. So here there is no direction, so they're just taking it to 4 digits. I always tell students to take it at least to 4 digits, because most of the time you are going to round to the hundreds most of the time with the relative frequency. So that's why they're taking it 4 digits also. So that's a good habit to get into. And another bar graph. Now this is of the relative frequency. This is of the head count. Like there's 12 brown M&Ms. There's 10 yellow M&Ms. There's 9 red M&Ms. There's 6 orange M&Ms. There's 3 blue M&Ms, and there's 5 green M&Ms. Now, did you just see how I did that? I looked over here and I matched up. That's what you will be asked on a test for a histogram or a bar chart. Okay, and that's standardized also. And I test you on bar chart and pie chart. I do test you on bar chart, being able to read a bar chart. So make sure you understand where I got those numbers from. I didn't get them from the slide. I got them from going over to the left and lining the bar up with this right here and adding them up, and you should be able to get the total. The question will read from the bottom, from the following bar chart, how many total M&Ms are there? And you have to read this bar chart and add them up, and that's your total. Again, I don't mean to insult anybody's intelligence. I'm just going over this material as if there's somebody in the class that's never seen it before. All right, now this is of the relative frequency. Now, not many times are you going to be tested on the relative frequency bar chart. About the only thing they would ask you is what percent of the M&M package is red? And you would say, okay, 20%. Or what percentage of the M&Ms are, I'm going to pick one that's simple. Well, I'll go with green. And you'd say probably around 11%, because it's right about there. So that's the kind of questions they would ask you on a standardized test. I'm not going to test you on frequency distribution, I meant relative frequency bar chart. But if they did on a standardized test, that's what they would ask. What is the percentage of red M&Ms? And you would say 20% or 0.2. So that's what they would ask you there. I want to hurry up and get to the actual. All right, I want you to write down this definition for standardized testing. A Pareto chart is a chart based on descending order. Pareto chart is based on descending order. It takes your data and puts it in descending order like that. Now, I'm not going to test you on a Pareto chart, but a standardized test will. They will ask you which one is a Pareto chart, and you're looking for one that starts up high and ends up low. If you put these in order by their quantity, and that's what a Pareto chart is. Remember me telling you that a lot of things in statistics, I believe they just made up and made it sound important? Well, here's one of them. Another one is histogram. A histogram and a Pareto chart, I think basically are just stuff they made up when they decided to create probability and statistics. So there you go. Make sure you make a note that a Pareto chart is taking the data and putting it in descending order. Side by side is used when you have two different years, two different places, two different sets of data. So write that down. Side by side, two different sets of data. And you have a vertical side by side and a horizontal side by side. Again, I'm not going to test you, and I doubt very seriously you'll be tested on a standardized test. The only reason you need to know this is if you're going to go into another probability and statistics based class. But side by side, two different sets of data. And here is an example. And you've got 1990 and 2006. Usually when you have two different sets of years, two different places, like New York versus California, okay, that's when you have a side by side, okay, or a horizontal side by side. Now, tomato, tomato, it's a preference. I will tell you this, a lot of people usually like the horizontal as far as being presented material, because which way do we read? Left to right, Hubert. That's right, class. And people can read left to right on a horizontal chart a whole lot easier than a vertical. But an analytical person, if you're presenting to a bunch of math people, they would probably, have a preference to maybe this one. But most people from layman's likes the horizontal because they can read. Not a high school graduate. People in 1990, there was 25% of the people that didn't have a high school education or a high school diploma. And in 2013, there's only 13% or 12%. So there's been a decrease since 1990 of people graduating, not graduating high school. There's been a decrease, so that means that's good. High school diploma stayed about the same. So people that did graduate, it stayed about the same. Some college no degrees dropped a little bit, but the associate's degree increased, and the bachelor's and the professional degree, meaning, usually after master's. So all three of those increased. So that's how you read it. And usually the horizontal is a whole lot easier on the eyes for people because you read from left to right. So you read the bars from left to right, and it's easier for people to grab onto. You will be tested on a pie chart and a bar chart. Can anybody tell me what is the first prerequisite for a pie chart? That means I want somebody to interact if they know. Think of your math teacher in high school and you go looking at a pie chart. Before you even start, what should you look for? Anybody?
Probably have to have percentages.
Yes, and something about the percentages. You're getting warmer.
Usually, they have to add up to 100%.
They have to add up to 100%. Write that down. Pie chart, before you even start to do any work on it, it has to equal 100%. So if you get a pie chart and it's got 50%, 25%, and 35%, you can't do anything with it. Put a big X through it and say, this is not valid, because a pie chart has to equal 100%. So here is an example. There is, now you're going to have to do the relative frequency on this. So let's do this one together, because I want to make sure you understand how to do a pie chart. A bar chart's not that hard to create. A pie chart, you have to do the relative frequency. So I'm going to write down this information while you're writing it down. Status and frequency. And never married. Good job on those people that's never married. When you should get married, I tell you, give you a little thing of advice. Women should not get married until they're at least 25 years old. Men should not get married, and this should be an amendment to the Constitution. Men should not get married till after 35 years old. Period.
Because so the age that qualifies you to be a president is also the age that qualifies you to get married?
Because you're not stupid. Most men grow out of their stupidity around 35. Now notice I said most. Most men do. Now every once in a while there's a guy that's mature by 35, but there's very few of those, and those are the ones that own their own grass cutting business by the time they're 23, and then they move into landscaping, and they're not stupid. Okay, they're not worried about putting smokestacks on their truck, or worried about putting $10,000 stereo systems in their at age, and not playing what is it called, PlayStation at 23 or 24. That's what I'm talking about. So 35, yeah, it is. And next, what's the next one? Married and widowed and divorced. And 55.3, I don't know how you have 0.3 of people, but you know how statistics is. 7, 13.9, and 22.8. And there's indicators, Mr. King. There's indicators. So besides the $10,000 stereo system in a $500 car, and sunglasses inside. You ever seen a guy wearing sunglasses inside a building? That's the #1 indicator. Girls, sunglasses inside a building, run. Get the hell away. Run. you know, you got all kinds of indicators. The smokestacks and the excessive videos and audio equipment in your car at age after high school. I understand it in high school, okay, because you know you have low self-esteem, and in high school, 18-year-olds and 17-year-olds have the lowest self-esteem. Period. So the indicators you don't count. But after high school, when they're in college or they're working and they're still doing that, they're still cruising the mall at 20, 23, that's an indicator also. Anyway, all right, so here we go. Women, it's real easy, guys. It's real easy for guys to find a woman with low self-esteem. They look like a Oompa Loompa. They have too much makeup on their face, and they have an orange face and a white neck. That's an easy indicator. Guys, if you ever see somebody like that, run, because they will key your car or bust your headlights out of your car because they're cray-cray. You know, they're crazy.
Has that ever happened to you?
No. Of course not. All right. Just remember, bars are dark, and you can't see the Oompa Loompas as good in the dark, okay? Just remember that. All right. Let me go to my handy dandy. There we go. So I want y'all, let's take our handy dandy calculators, and we're going to work through this because I want to make sure everybody can get the relative frequency. So we're going to take our handy dandy, and we're going to move this down a little bit, like there. And we're going to take 55.3. And it's hard to do this with a mouse. So if you would go ahead and check me, 127.7 plus 13.9 plus 22.8. 219.7 is your total. Somebody check me, please. I need somebody to verify that that's correct because I don't want to.
That's correct.
Okay. Now, each one of these numbers are going to be divided by 219.7. So your relative frequency is going to be 55.3. 55.3 divided by 219.7. 0.25 or 25%. Since you are doing a pie chart, since you are doing a pie chart, you need to change it to percent because pie charts are, you know, done in percent. Okay, so the next one is 127.7. Now that's not correct. Wait a minute. How can I have 219? Oh, that's 219. Whew. I thought I was seeing things. 127.7 divided by 219.7. And I need somebody to do the last two for me because I'm not going to do, this takes too long with this mouse. And 0.58. Somebody do the last two for me. What's 13.9 divided by 219.7? Two digits, please. Round to
0.06.
0.06. And the last one.
0.10.
And if you add all those up, you should get 1 or 100. So this is 58%. Doesn't look like it equals 100. Are you sure you rounded correctly? 6%. Well, that's 19. Looks like it's right at 99%. Somebody check the rounding, please. And 10%.
Yeah, I rounded correctly, but
okay. All right.
If it's within 0.02%, it's accepted, correct?
Yeah, I didn't tell y'all that. I'm sorry. All right, so this is 58%. So we know that this is 50%. So I'm just going to take, and I'm going to move that line there. Please mute your microphone, please. All right, that'd be 58% right here. And then this is 25% right here. So I'm just going to draw a line right there, and that's 25%. And then 6% would be here, and 10% would be here. And that's what your bar graph would look like in some form, some way. Okay, so let's look and see what they got. Oops. Where's my PowerPoint? There it is. And there we go. And you can see that ours looks about the same, except they kind of flipped. They're 11. Let's say they rounded that to 11. So, you know, we'll change that to 11 just to coincide with the slide. And change that right here. And that's how you do pie charts, bar charts, and basically bar charts are on the frequency, on the head count, usually, where your pie chart is usually on the relative frequency. And that's pretty much what we're going to do. Okay, now 2.2, I want to get to what, this is what I want to get to today. There we go. All right, now, what we did in 2.1, we did qualitative data. So in 2.1, we went over qualitative data. Go ahead and write that down. 2.1, we went over qualitative data. Now we're going to go over quantitative. Okay, so in 2.1, we kind of viewed over qualitative frequency distributions. In 2.2, we're going to look at quantitative frequency distributions. You know, the ones that have what instead of categories? Classes. Now remember, with quantitative data, we can do more mathematics with quantitative. The only thing we can do with qualitative is find the relative what? Frequency. That's the only thing we can do with qualitative data. Quantitative data, we can find more things. So that's what we're doing in 2.2 is we're finding more mathematical things. Now, let's go ahead and use one of our examples. I'm going to use that little one, number 4. Well, no, I better use number 1 because it's a little bit less overwhelming. So number 1 that I sent y'all is classes and frequency. So we'll just use the age because they look like their ages. 10 to 14, 15 to 19, 20 to 24, 25 to 29, and 30 to 34. And the head count is 4, 8, 5, 2, and 1. This is a quantitative frequency distribution. And it is a test question, and it is a standardized test question. And you will probably see on my test and on a standardized test, one of each at least. And they're going to ask you the relative frequency first off, N and the relative frequency. So you can go ahead and we'll write this in red. One, the first thing they're going to ask you is N, or the total. The second thing they're going to ask you is relative frequency. And that's for all qualitative and quantitative. So for now, with a qualitative, they may ask you more in terms of pie chart and bar chart. Okay, so if you're doing qualitative, they may ask you to do more in terms of a bar chart or a pie chart. In quantitative, they're going to ask you to do more math, which includes the class width, class boundaries, and the midpoints. Okay, so for the qualitative, you basically do the N and relative frequency, and you might be asked on a test about the bar chart and the pie chart. With a quantitative, you're going to ask to do more math, including the N and the relative frequency, but you're going to also be asked to do the class width, class boundary, and the midpoints. And that's where a lot of people, it's overwhelming when I show it. So that's why I got the videos, so you can pause it and, go back and look at whatever you need to look at for the 1 or 2 people that's going to go and actually look at the video. All right. So let's go back to black. It's a good song. And we're going to highlight some things. I'm going to take my yellow highlighter and I'm going to highlight these guys. Can somebody that's had probability and statistics before, can you tell me what these guys are called? Anybody?
Is it lower class boundary?
Lower class limits or lower class boundary. Most people call them lower class limits because it's easier to say. Lower class limits. So I'm going to go down here and I'm going to write a long arrow. Lower class limits. LCL. That's lower class limits. And if those are called lower class limits, what do you think the ones on the right are called?
Upper class limits.
Upper class limits. Those are called upper class limits. Which I'm going to call UCL. So now that you've got those, you know how to find N. So N is going to be, that's 12, 17, 20. So N is equal to 20. N is equal to 20. And you're going to put in a new column here. And that's going to be called relative frequency. And you're going to do 4 over 20, 8 over 20, and 5 over 20, and 2 over 20, and 1 over 20. And you're going to change that to a decimal, usually rounded to the hundredths, or read the directions. Okay, so we're not going to go over that because we've already covered that. Okay, and if you're, it may ask you to do a pie chart. It may ask you to do a pie chart and a bar chart or whatever for this class. You may be asked to do that. So all of this you can apply to a qualitative or a quantitative. It may ask you on a test to do a bar chart. So if it asks you to do a pie chart, you wouldn't change these to a decimal. Well, you could change them to a decimal and just mentally change 0.25 into 25%. That's up to you. Okay? So what about this stuff? Well, we're going to do that on the next page because I don't have enough room here. So we're going to go over to the next page. I'm probably just going to, give me a second. This is the old copy and paste routine. Before there was computers, you just folded a piece of paper up. I know some of y'all never seen this before, but and I really suck at it, so I wasn't one of those people that made the paper origami things in class. All right, there you go. And we need to find the class width first. And I take two corresponding, I don't know what's wrong with my writing skills this morning, two corresponding, so you better check my spelling because my synaptic whatevers are not working this morning. Two corresponding, I use the lower class limits. You don't have to, and I'll show you that in a minute. And subtract. And you always want the positive number because class width cannot be negative. Okay? Actually, it's not positive or negative. It's like distance. It doesn't have a sign. But you don't want a negative in front of it because you can't have -5 on a class width. You can't have that. Class width has to be positive because it's, it's wide. Negative would be overlapping. All right, so class width, and I usually pick the first two because what's the KISS method? Keep it what? Keep it simple, Hubert. That's right, class, and thank you for your interaction. I do appreciate it. I'll suck. All right, so here is my first two. And I'm going to put two corresponding. Okay, so I picked two. You don't have to pick those. You can pick 19 and 14. You can pick 15 and 20. You can pick 19 and 24. You can pick 20 and 25. You can pick 24 and 29, 34 and 29, 30 and 25. You cannot pick 34 minus 14. They're not corresponding. They're not one right after the other. All right, so you have to pick two corresponding, subtract. 15 minus 10 is equal to 5. So our class width is 5. Simple as that. Basic math, I picked those first two. You don't have to. Let's say you're Mr. King and you like to do everything the difficult way. So I'm going to pick 29 and 24. See, you still get the same answer. There is no way to screw up the class width unless you're one of these people that go out of their way to screw it up. There's no way. Anybody got a question about class width? Now, the class width, the reason you get the class width first is so you can calculate your other things. Okay? You got to calculate other things besides class width, and that's class boundaries. Now, class boundaries, make sure you write this definition out because you're going to screw it up if you don't. Class boundaries And if I spell boundaries correct, I think that's right. All right, class boundaries. How do you do it? Well, first of all, you have a guide. You have a guide to go by. If you have whole numbers with your lower and upper class limits, your class boundary is going to be to the 10th, and it's usually going to be 0.5 added to your number. Now, this is a pattern, so you need to make sure you understand the pattern, because I'm not going to write down every single one of them, because that would cover to infinity, and I'm not going to do that. If you have numbers in your lower class and upper class limits that are to the 10th, then you use class boundaries to the 100th, and that is 0.95. If you have class boundaries that are to the 100th, what do you think you're going to use for, if you have upper and lower class limits to the 100th, what do you think you're going to use for class boundaries? 1,000. There's the pattern. And that will be 0.995. So the next one, I'm not going to write down the next one. If you have, and none of you are going to see these because you never see upper and lower class limits to the 10,000. But if you have to the 1,000th, you're going to go to the 10,000th, which would be 0.9995. Okay, so the pattern follows this 95 and 9995. You just add nines as you go. All right, so what do? I usually look at the first lower class limit, and then I just use common sense. What's my first lower class limit? 10. What whole number comes before 10? That's really hard, people. What whole number comes before 10?
9.
And you add that 5.5 to it. So your first class boundary is 9.5, and now you're going to add 5 until you get to 34.5. So let's do it. Let's see what happens. So 9.5 plus 5 is 13.5. I'm sorry, 14.5. And 14.5 plus 5 is 19.5. And 19.5 plus 5 is 24.5. And 24.5 plus 5 is 29.5. And 29.5 plus 5, look at there, 34.5. And that's what we were wanting, because that one is right here. And that's how you find your class boundaries. Please don't make this hard, because it's not. So the first thing you do for your class boundaries is you first establish what do you have. Most of the time you're going to have these two. Most of the time in your homework and test, you're going to have whole numbers probably, and then you might have some that are to the 10th. But this one is whole numbers. See, 10 and 14, they're whole numbers. Pick the first one. I picked the 10. What comes before 10? 9. Add the 0.5 because you're dealing with whole numbers. So that would be 9.5. And then you just start adding the class width. Okay, and the last thing is called midpoints. And I picked the first two. Lower class limit and upper class limit. And that will be 10 plus 14 and divide by 2. And that's what you do. You take your first one and your second one. You take your lower class limit and your first upper class limit, and you add them together. This is called midpoint. Y'all should remember this from algebra. And you add them together, and that's going to be 24 divided by 2 is 12, right? And you put a 12 right here and a comma, and then you add your 5. 12 plus 5 is 17. 17 plus 5 is 22. 22 plus 5 is 27. 27 plus 5, I have no idea, 32. And 32 is between 30 and 34, so you stop. And that's it. All right, now you do the second one, number 2. So I want you to go ahead and copy down number 2. I'm going to copy it down here in just a second for you. And you're going to have 2 of these in your notes so you can refer back to, as well as the video that you can rewind and forward and pause. And so there should be no reason, besides LAD, no reason that you can't do all of this by the test. All right, the second one, let me go ahead and just put it right here for you. For those that didn't print out the extra problems, there you go, or draw them. Number 2. Go ahead and copy that one down, and we're going to do that one. And while y'all are doing that, I'm going to check the roll right quick. I think we only got one person that is not checked in. I think that's Dorsey. But let me check to see if somebody has dropped this class. No, I think everybody's been here this week. Let me look and see. Yeah, Dorsey's the only one. And Dorsey's not here, so that's it for this week. Oh, God, what a surprise. Tri-County has logged me out. Does that surprise anybody? Oh, man. I'm not going to worry about it. The heck with it. Okay. So let's write that one down. And that's going to be 30 to 39, 40 to 49, 50 to 59, 60 to 69, and 70 to 79. And that's 2, 3, 7, 5, and 1. So 7 and 3 is 10, 15. I got 18. What'd y'all get?
The same.
Yeah, I got it.
Okay. And your relative frequency is 2 over 18, 3 over 18, 7 over 18, 5 over 18, and 1 over 18. change to a decimal, round to 2 usually, and percents used for pie chart if asked. So that's your class, that's your frequency, and that's your relative frequency. All right, so that should be like second nature to you because we did that in 2.1. Now, class width. Somebody tell me the class width.
Is it 10?
Yes, ma'am. What did you subtract to get 10?
The lower class boundaries.
Thank you. Thank you for the interaction, Miss Johnson. You know the other students are going to get mad at you, right? They'll probably say bad things about you. But you're tough, right? Okay. So 40 minus 30 is equal to 10. And that's your class width. All right, so let's do the class boundaries. Class boundaries. Well, that's going to be, I'm just going to go down here and I'm going to put a brace. And what is my first number? 30. Somebody tell me what comes before 30. What whole number comes before 30?
29.
And I'm going to add a 0.5 to it because they're whole numbers. And I'm going to add what to the first number? 10. The class width.
10.
So that'd be 39.5, 49.5, 59.5, 69.5, and 79.5. Sorry, I ran out of room there. I suck. And the class width, I mean the midpoints are going to be equal to the first number is going to be 30 plus 39 divided by 2. And somebody tell me what that is. 69, well, 68 would be 34.5. Somebody help me out. 34.5? Is that right?
Yeah.
Okay, and now I'm going to add what? 10. 44.5, 54.5, 64.5, and 74.5. If you will look, are we using any kind of algebra or calculus or trig or geometry? Or are we just using basic math? We're just using basic math. Thank you, Miss Glenn. I appreciate that. See what you do, Mr. King and Miss Johnson? You're starting a trend. There are actually students that are interacting with me. Only took 2 freaking weeks, but they're interacting with me. Okay, that's good. Rest of y'all weaned on a pickle, and you're going to have a closet office down at the end of the hall near the stairs and the bathroom because you don't communicate. All right, so here we found N. We found relative frequency. We found the class width. We found the class boundaries. And we found the midpoints. And you should feel good about yourself. Now you're talking about out of chapter 1 and 2 homework questions to be on the test. You're probably talking about 2 or 3 questions right here. 2 or 3. So it's worth knowing. So that's why I gave y'all some extras. Now I usually don't pick the extras to go over in class. So you got 2 extra here instead of 4. So you can do those. And if you want to do those for class Tuesday, if you have problems, just let me know and we'll do them, but they're pretty straightforward. I'll go ahead and tell you, what's the class width on this one?
Seven.
Good. What's the class width on this one?
11.
So go ahead and write that down. The class width for this one is equal to 7, and the class width for this one is 11. That's half the battle right there, is finding the class width. So with the videos, with the 2 questions that I went over today, you should be able to do these 2 problems. And if you want me to go over them next Tuesday, just ask. I'm sorry, communicate. Because that's what asking is, that's communication. All right, let's go back to the slides. Because we just did basically all of 2.2 except for the little bitty stuff. And here, lower class limit, upper class limit, class width, 35 minus 25 is 10. I'm going to leave that. Let me go ahead and I'm going to put that on the board there for a few minutes or a few seconds. So that way on the video, for those 1 or 2 people that watch the video, you can pause it and you can read everything that I just told you. You can read it right there to make it official. Now, I try on the test not to use BA numbers, okay, because I know you'll use your calculator and anybody can use a calculator. A 5-year-old could use a calculator if you tell them what to put in it. So that's not my point is not to make you use the calculator. My point is to make you learn the process, right? So I'm going to leave that on there. And 5, 4, 3, 2, 1. Move on. And they'll give you a whole bunch, and you got to make a frequency distribution. And there's the classes. And there's the relative frequency. This is just another example. And they're going to find the class. Okay, there's not a frequency. However, it's just another example. I'm not going to give you one like this on the test. This would take forever to do. If I wanted to give you one problem for the whole test, this would be the problem. You know, give you this and give you this, and then you find the relative frequency. The class boundary would be 5. I'm sorry, class width would be 5. And then you would have to find all those class boundaries and all of those midpoints. And that would take a few minutes. And they're telling you that's... Now, write this down because you may see this on a standardized test. This is how you find the class width if you're not given all of the classes. You take the largest data and the smallest data and you divide by the number of classes. Write that down because that's what you use if you're not given all of the classes. Class width equals the largest value minus the smallest value over the number of classes. So if they give you, 5 and 20, 5 is the smallest number, 20 is the largest number, then that's going to be 20 minus 5, and they should tell you, okay, they don't tell you how many classes, number of classes between 5 and 20, the smaller data set, the fewer 5. Okay, they're not giving you that. Okay, so I thought they were going to give you an example. So I'm not going to worry too much about that. Okay, let's write down stem and leaf. Write down stem and leaf. And what is a stem and leaf? Excuse me. This is a standardized test question. It is not a Hubert question on the test, but you might see it. Let me see if I can just show you a stem and leaf right quick. There. That's a stem and leaf. So my lowest value is 20. My highest value is 80. And I'm just going to put, there's a 120, there's a 28 in my data. There's a 38, a 38, a 38, a 33, a 39, a 32, a 39, a 32, and a 32. That's how you read a stem and leaf. 47, 48, 42, 40, 43, 40, 41, 40, 44, 47, 40, and 46. So I'm telling you how many, what my data values are by looking at this stem. That's how it works. Now to go the other direction, you take your data and you find your lowest value, which is 20, because you have to go below your lowest value. Your lowest value is 28, but you just can't go 28. You have to put a 2 here for 20 and then go by tens. And that's why you put the 8 right there. So that's 28. So I got one number that has a value of 28 in my data. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got 9 values that are in the 30s. And I've got 10, 11, 12. I got 12 data values that are in 40s. And I have 12, 13, 14, 15, 16. I have 16 values that are in the 50s, and so on. That's called a stem and leaf. Now, I'm not going to ask you how to make one, but if I give you, let's say I give you the following values: 21, 25, 26, 30, 32, 34, 40, 41, 45, 52, 56, 60, and 61. All right, there's the following. That's just a table of values, and it's in order because it's easier when you put the data in order. And what's my lowest value? 21. So I draw my stem and leaf, and 2 is 20, 30, 40, 50, and 60. And now I just put my values. 20, I only got one 20 value, and that's a 21. Oh, I'm sorry, I got more than that. 25, 26, so that's going to be a 5 and a 6. So my 3 values in the 20s is 21, 25, and 26. So 30s would be 0, 2, and 4. And then 40s would be 0, 1, and 5. And then 60s are, that's an oval, these are circles, these are ovals, would be, oops, that's a 60 right there, so that don't count. 50 would be a 2 and a 6, and then 60 would be 0 and a 1. And that's a stem and leaf plot. The advantages of a stem and leaf plot is you can turn it to the side and you can see your curve. That's why you do a stem and leaf plot. Turn it to the side, you see the curve a whole lot better. And we'll get to curves later. That's a stem and leaf plot. Just be able to draw one and be able to understand how it works. 21, 25, 26. Now, the difference between a stem and leaf plot and a dot plot, stem and leaf, and a dot plot, can anybody tell me the difference? They're very similar, but what's the difference? Anybody know? Instead of numbers, what do you have? Dots.
Nice.
So you set it up the same way. 2, 3, 4, 5, 6. And you got 3 dots here that represents 3 numbers that are in the 20s, 3 numbers in the 30s, 3 numbers in the 40s, 2 numbers in the 50s, and 2 numbers in the 60s. Now, of course, the dot plot doesn't help you very much. It still shows you the curve, but it doesn't show you the numbers. So the best one out of the two is the stem and leaf. These are both SAT questions. I'm sorry, standardized test questions. Be able to define, be able to, visualize, and be able to create. Not really. If once you put your data in order, it's real easy to see the lowest number and the highest number. So you can, and that dictates those two numbers right there. You can't have 61 shown if you don't have a 6. If you didn't have that 6, you couldn't show 60 and 61. So whatever the lowest number and the highest number is, that's what dictates that 2 and that 6. What if I had an 11 right here? Then my number right here, I would have a 1 right there because I have to have my 10s represented right here, and that would be a 1 right there if I had a 11. And the same thing, what if I had a 73 right here? Then I would have to bump this up to a 7 and put a 3 right there if, that should have been dotted because I added that. So you would have to, you always go with the lowest and the highest. Okay. What's next? Probably some more of the different types of, where did my stem and leaf go? There we go. I don't use a split stem and leaf, and I don't test you on a split. That, to me, when you do this, you mess up the whole point of doing a stem and leaf. But I want you to understand what it is, okay? Let me give you an example. Let's take the same example we just did. And I am watching the clock because I know some of y'all are starting to convulse. 21, 25, 26, 30, 32, 34, 40, 41, 45, 52, 56, 60, and 61. Now, for each number, I'm going to give 2 digits. The bottom digit is for 0 to 4. So that would be that one. And then I've got a 5 and a 6. So that 5 right there and that 6 will go right there. 0, 2, 4. So those would all go here. 0, 2, 4. I don't have anything 5 or above, so nothing goes there. 4. I have a 0 and a 1. 0 and 1, and then I have a 45, so that 5 goes there. 52, 2 goes there, 6 goes there, and 0 and 1 go there. That's called a split. And as you can tell, it kind of messes up your curve. I'm not a big fan of these, okay? I'm not a big fan of half stem and leaf. That's what it's called, half stem leaf. But you might see it on a standardized test. And the biggest thing is you split it based, or split. Some people call it a split stem leaf, and some people call it a half stem leaf. Split, you split it at 0 to 4 and split and go from 5 to 9. So this one is 0 to 4 and this one is 5 to 9. And the only place, I really don't know of any application that you would do this. It's just another preference. But I don't like it because it messes up your curve on your data and turns it into something different. So I'm not a big fan of it, but I'll need to show it to you in case you see it. And if you know, it says once a frequency, and it doesn't show you, does it show you anywhere on these slides why you would use a split stem and leaf? No. So, okay, when data appears rather bunched. Okay, bunched. There you go, right there. I'm just not a big fan of it. Let's move on. There's your dot plot. I've already shown you a dot plot. There's a dot plot. The only thing I don't like about the dot plot is you can't look at the dot plot and reconstruct your data. You can't do that because you don't know what the dots represent. All it represents is a number. So between the stem and leaf and the dot plot, I told you the stem and leaf is the one to go with. Here we go. Now we're getting to test questions. These, write these down. Those are four. I'm sorry. Okay, now it's ready. Oh shoot, hold on. Those are your four, there's four test questions right there. So write them down. And they're also standardized. Yes, Miss Maroney? Oh, I thought you said something. Those are four test questions and four standardized test questions. Make sure you know which ones are which. That's not Michael Jordan behind you, is it, Mr. King?
No, sir, that's LeBron. But I do have a poster of Michael Jordan.
Well, that's good. Greatest of all time. I think Michael Jordan, Tiger Woods, Peyton Manning, Tom Brady.
That is your opinion.
Greatest of all time.
He is my second favorite player, and in my mind, the second greatest player of all time. But the great thing is, it's an opinion. It's not fact.
Yeah. I think you gotta put class in there, and I think he's got LeBron on class. I'm sorry, but I think he does.
What do you mean by class?
Huh?
What do you mean by class?
There's lots of different things that attribute to class.
If you're talking about like how he interacts with people and his mannerisms, and is that what you mean by class?
That's part of it, yeah.
Well, I think he was a gambler and a drunk. So,
okay.
If you want to go down that route, then no, he's not better than LeBron.
I don't remember seeing him drunk, but I really don't.
Did you watch?
I remember he used to gamble on the golf course, but if you ever been on the golf course?
Did you watch what was the documentary that just came out?
I saw most of it. I didn't see all of it.
Did you see his eyes?
No.
Okay, well, you should go back and look at the documentary and look how yellow his eyes are.
Well, that could be a medical condition. He might have.
That could be something wrong with his liver.
Yeah, exactly. What? Yeah, he had a problem throughout his whole career of like showing up to practice and even games intoxicated.
Never heard of that.
Yeah, but again, he's my second favorite player of all time. I only bring that up because, you know, class was brought up. I appreciate him a lot, and I love watching highlights and stuff like that. I didn't grow up watching him.
Yeah.
But I
think it would be different. I think it's always different when you grow up watching somebody.
Yeah, absolutely.
I think it's always going to be a little bit favored. And again, I listed a lot of people that I grew up watching, and I just think Tiger Woods had his up and down. And I honestly think when you have that much money and you have that much, free, whatever you want to do, you're going to screw up.
Yeah,
I don't care
absolutely.
who you are.
No one's perfect.
All right, so we're going to stop here because I got a lot of stuff to talk about right here. So we're going to stop, and I need somebody to write down slide 63 of 2.2, slide 63. And let me see how much we got left in 2.2. Okay, so right now, there's only like 2 slides left. Right now, everybody should be working on 1.1 through 1.4. I'm going to write this down so it will be in the video. Everybody is responsible for, right now, 1.1 through 1.4 homework. And 2.1 and 2.2 homework. So if you want to know where you should be right now, everyone, I didn't see any 1.1 through 1.4 homework questions. So that means everybody understands that. Everybody should be working on these 2 right now for Tuesday. Everybody should be working on 2.1 through 2.2. Now, if you're saying to yourself, oh my gosh, I haven't finished 1.1 through 1.4, then you are already behind. Okay? You need to be working, because I went over 2.1 material this week, and I finished up 2.2 today. So y'all are already behind. 2.3 will probably be Tuesday. And then that means Chapter 3 is next. Now remember, Chapter 3 is 80% of your Unit 1 test. So we're fixing to get into the math with Chapter 3. All right, y'all have a good weekend, and I'll see y'all later. If you got any questions, hang around. Rest of y'all, have a good weekend.
Thank you, you too.
All right, see ya.
You too.
Have a good one.
Take care, Ms. McClure.
See ya.